Hello, I'm Dexter Guilas, and I'm doing the FRQ from Calculus AB 2004, question number 1. And the skills we need to finish this problem would be entering an integral into a calculator, entering a derivative into a calculator, the average function value formula right here, the slope formula right here. And so the question is, the traffic flow is defined as the rate at which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f defined by f of t equals 82 plus 4 sine t divided by 2 from the interval 0 to 30, where f of t is measured in cars per minute and t is measured in minutes. So letter A. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? To solve this problem, you would need to take the integral using your calculator, using the limits 0 to 30. So let's go to our calculator, math, use number 9, from 0 to 30, put the function in, which is 82 plus the 4 sine of x divided by 2 from d of x. Now from this whole number, you get 2,474, which is the answer right over here. Now for letter B, is the traffic flow increasing or decreasing at t equals 7? And give a reason for your answer. Now to find out whether the traffic flow is increasing or decreasing, you need to find the rate of change of the traffic flow. And to do that, you need to take the derivative of this function. So once again, let's go to our calculator. Math, number 8, d of x, 82 plus the 4 sine of x over 2 from x equals 7. Now we get negative 1.8729. Since we have a negative number, we know that the traffic flow is decreasing because the traffic flow is less than 0. Now for letter C, what is the average value of the traffic flow over the time interval 10 to 15 minutes, and indicate the units of measure? Now to do this, you need to use the average value formula and use the calculator once more. So 1 divided by 5, the integral from 10 to 15 of 82 plus the 4 sine of x over 2. Now we get 81.899 as our answer. And that would give us our average traffic flow, average value for the traffic flow during the interval 10 to 15 minutes. And don't forget the units of measure because it is very important since it was required by the question. Now for letter D, what is the average rate of change of the traffic flow over the time interval 10 to 15 minutes, and indicate the units of measure? Now to do this, we need to use the slope formula, which is y2 minus y1 divided by x2 minus x1. So let's plug that into a calculator. 82 plus the 4 sine of 15 divided by 2, and 82 4 sine of 10 divided by 2. Subtract these numbers. And then divide it by 15 minus 10, which is the slope formula. And then you would get 1.5175. Now that is the average rate of change of the traffic flow during the interval. And don't forget the units of measure, which is cars per minute squared, because the original units of measure were cars per minute, but now it's cars per minute squared because you're taking the derivative or the rate of change. Now for the point distribution, for letter A, you get 1 point for the limits, 0 to 30, 1 point for the integrand, which is right here, and 1 more point for the answer, which is 2,474 cars. For letter B, you just need to get the answer and the reasoning, 1 point for the whole problem. Letter C, you can get 3 points possible, 1 point for the limits once more, 10 to 15, 1 point for the correct integrand, which is 1/5 to 10 to 15 f of t dt, and for the answer, which is 81.899 cars per minute. Letter D, you just need to get the right answer, which is 1.518 cars per minute squared. And for both C and D, it's the units of measure is all worth 1 point. So if you didn't have that, you missed 1 point from the whole problem. Thank you and bye.